right, on to part 2. Question number 13. We're asked to write log base 3, 81 equal 4 in exponential form. Okay, so let me write that down so you can see it clearly. All right, log base 3, 81 equal 4. We're going to start with the 3, move around to the 4. In log form, this number on the right-hand side of the equal sign is always your exponent. So we'll start with the base 3 raised to the 4th power equal, let's keep going, to 81 equal 81. So now we have it in exponent form. What that means is 3 times 3 times 3 times 3 equal 81. That is a true statement. So I'm just double checking my work. Okay. Now to question number 14. We're asked to write exponent form 2 to the 4th power equals 16 in log form. So we're writing the inverse of each of these functions. All right, so we start with log. Our base is 2. The base goes here, a little bit below that line. The answer goes here, equal, and then the exponent goes here. So those are inverses. Let me check my work. 2 to the 4th power equal 16. So that's what we get when we go back in reverse. 2 times 2 times 2 times 2 equals 16. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. So let's check. All right, number 15, we're asked to see if we can factor. So let's look at a couple of problems. We're going to start with a simple one. Let me write this down, is x squared plus 2x minus 15. If the coefficient is 1 here, I'm going to factor the constant into 2 numbers. So let me make a T-chart underneath. 2 numbers that multiply to give me negative 15 and add to give me 2, positive 2. All right, so I'm going to start with the factor 1 times 15, and one of those needs to be negative. Looking at that middle term, the larger factor needs to be positive, so when we add, we get a positive middle coefficient. So this is going to be negative 1 times positive 15, gives me negative 15, but it adds together to give me positive 14. It's not what I'm looking for. I'm looking for positive 2. Okay, now let's move to negative 2, doesn't go in. Negative 3 goes in 5 times. Negative 3 times 5 is negative 15. Add 5 to negative 3, and we get positive 2, and that's what I'm looking for. So here are the numbers I'm going to put into binomial. Okay, so x minus 3, and then x plus 5. Okay, we factored this trinomial. You can FOIL it out, or you can multiply it, box it out to check your work. All right, now let's go to part B. All right, let's look at question number 16. We're asked to graph f of x equals 4 to the x. So let's move over to our graphing calculator. All right, now that you've put this into your graphing calculator, we can see this is an exponential function. It's going to cross at the y-axis. The y-intercept is 0, 1. It's going to increase exponentially. All right, we're asked about the domain. So what can our x's be? So our x's can go from negative infinity to positive infinity. And we have an asymptote at a horizontal asymptote at the x-axis, and that is y equals 0. We don't have a vertical asymptote. The range is going to be from 0 to infinity, and we're going to write down the end behavior. So take a look at this. We're going to go back to our question. So the domain for an exponential function is always going to be that basic exponential function is going to be from negative infinity to positive infinity. The range without any transformation is going to be from 0 to positive infinity. The horizontal asymptote is going to be y equal 0, or the x-axis. And the end behavior, as x approaches infinity, positive infinity, y approaches positive infinity. In other words, as we go in this direction, y is going up. Okay. Now on number 17, we're asked to graph the function f of x equals log 4x, and then we want to do the same thing. We want the domain, the range, the horizontal asymptote, and the end behavior. All right, now if we have the exponential function, okay, and if I look at the log, this is the inverse, because this would be 4 to the, let me see, 4 to the y equal x. This is going to be f of x is going to be y, so let me write it that way. Log base 4x equals y. So this would be 4 to the y equals x. So we're just essentially switching our x and our y's. Okay, so this is going to reverse. Our domain is going to now become what the range was, from 0 to infinity. And the range is going to become what the domain was, from negative infinity to positive infinity. The horizontal asymptote becomes not y equals 0, but x equals 0. And then the end behavior is going to stay the same. As x approaches infinity, y approaches infinity. Now let's look at that graph, see what that looks like. Let me put this in. So f of x equals log base 4 there we go, log base 4x. All right, so you can see that's a reflection over y equal x, because those are inverse functions. Okay, so here for the exponential function, it's going to cross the y-axis. That y-intercept is 0, 1. But now the x-intercept is 1, 0. So everything, the x and the y's are switching. Okay, now let's go back and look at what we wrote down. The domain is going to go from 0, because we have a vertical asymptote at x equals 0. Okay, so it's going to go from 0 to infinity. X, we don't have anything less than 0. Okay, the range is going to be negative infinity to positive infinity. It's still going up, even though it's going up slowly. Okay, now I wrote down horizontal asymptote. The asymptote is actually going to be a vertical asymptote, or the y-axis. And then as x gets bigger, y gets bigger. As x approaches positive infinity, y also approaches positive infinity. All right, now we're going to graph, look at number 18. We want to state the domain for f of x equal log x minus 8 plus 11. So I'm going to start with the basic parent function log of x. Okay, and then we're going to add or subtract 8 inside the parentheses with the x, and then we're going to add 11. Now, we're going to have to zoom out to see that shifted. It shifted to the left, I'm sorry, to the right, 8, and then it shifted up 11. So let me zoom out a little bit. So it went to the right 8 units, 1, 2, 3, 4, 5, 6, 7, 8. So we have a vertical asymptote at x equals 8. Okay, the domain is going to be from 8 to infinity, what x could be. And the range is going to be, looks like it stops right here. It's undefined at y equal, see, that's -5, -4 to infinity. We're going to solve for x. Log base 6x plus log base 6x plus 2 equals log base 6, 24. Okay, so that's question number 19. All right, log base 6x plus log base 6x plus 2 equals log base 6, 24. Let's use our log properties. Addition means that we can multiply these two things together. So this is going to be log 6 of x times x plus 2. So let's multiply, distribute this x into both terms. So we have x times x is x squared plus x times 2 is 2x. All right, that's equal to log base 6, 24. Okay, now we can take this off. Okay, and then we have x squared plus 2x equals 24. Subtract 24 from both sides. This is going to be 0 on the right. On the left-hand side, we have x squared plus 2x minus 24. So now we're going to factor the left-hand side. Okay, the factors of -24 that multiply to give you -24 that add to 2. It's not going to be 1 and 24, not going to be 2 and 12. See, let's try 3 and 8. And that middle term is positive, so this 8, the larger number, needs to be positive. Smaller number needs to be negative, but when you add those together, you still get positive 5. We're looking for 2. All right, what about -4 and positive 6? They multiply to give you -24, and they add together to give you a positive 2. So we can factor that into x minus 4 times x plus 6 equals 0. Set each factor equal to 0 and solve for x. So if you set x minus 4 equal to 0 and add 4 to both sides, you get x equals 4. If you set x plus 6 equal to 0 and subtract 6 from both sides, you get x equals -6. Okay, we're going to toss out the negative because taking the square root of a negative number gives us an imaginary number. This is extraneous. We're only going to take our positive solution. So x equals 4 for number 19. That's our only solution when we factor. If these were both positive, we would take them both. All right, let's move on to question number 20. All right, we want to solve for x, and we have e to the 1.5 x equals 6.42. All right, we need the natural log. Let's take the natural log of both sides. So I'm going to take ln e to the 1.5x, take ln to the 6.42. Now that I've done this, the 1.5x comes out, equals ln 6.42. Okay, now I'm going to divide both sides by 1.5. 1.5 over 1.5 is 1, so x is equal to ln 6.42 divided by 1.5. Put that into your calculator to get your answers. So let me move over, open up Desmos, make sure that you've got that written down. All right, so we're going to put in ln. You can type in ln, or you can look for the function. I'm going to go down here and find the function. So ln of 6.42 okay, divided by 1.5. Right, and so I'm going to round that off to approximately 1.239, but that 6 brings that 9 up and turns that into a 0, turns that 3 into a 4. So 1.24, round that off. All right, let's look at 21. Okay, it's asking us to solve for x. We have 1.32 e to the 2.1 x plus 4.5 equals 6.72. Okay, we're trying to solve for x, so let's start by subtracting 4.5 from both sides. So subtract. This is going to become 0. Bring down the 1.32 e to the 2.1 x equal, okay, 6.72 minus 4.5. 6.72 minus 4.5 is 2.22. Okay. All right, divide both sides by 1.32. This is going to be 1. It's going to cancel. So I'll have e to the 2.1 x equals 2.22 divided by 1.32. Maybe I'll just leave it like that because that decimal is repeating, 1.32. Okay, we'll come back to that in a second. All right, now I'm going to take the natural log of both sides. Okay, so this is going to cancel. 2.1 x equals the natural log of 2.22 divided by 1.32. And then finally divide by 2.1 to solve for x. Okay, let's move back over to our calculator. So we're going to take this, and we're going to take the natural log of 2.22 divided by 1.32. Okay, let me put all that in parentheses. And then we're going to divide that by 2.1. Okay, so our final answer is 0.248 if I round to the nearest thousand. Now I'm rushing through this, so if you see any mistakes that I make, point them out. Make sure that you're following the steps for solving equations using your calculator to get the right answer. All right, we want to condense on number 22. So we're going to take an expanded log and we're going to condense it back down again. So we have the natural log of 4 plus 3 times the natural log a minus 2 to the natural log b. All right, so we have the natural log. We've got the 3 that we're multiplying right here, so I'm going to bring that and put it up as an exponent. So I'm going to write it this way, natural log of 4 plus the natural log of a to the third. Just checking my work here, minus 2 natural log of b. I changed it to this because that looks too much like a 1 to me. All right, so when we're adding, we're going to be multiplying. So this is going to be 4 times a to the third. So this is a natural log of 4a to the third, and then minus 2 natural log b. With subtraction, we're going to divide. We put these two together with multiplication. Okay, now I've got the natural log, and we're going to divide 4a to the third divided by, oops, bring that 2 up here. Just like we did with that 3. Okay, so that's going to be divided by b squared. So we've put that back together. We've condensed it. All right, number 23. We're going to expand log base 4 9x squared y to the fifth. Okay, so expanding, we're multiplying these two terms together. Okay, so let's take log base 4 9x squared plus log base 4 y to the fifth. Okay, now let's take that 9, bring it up here, multiply it times the exponent, which is already there, the 2. So this is log base 4 x to the 9 times 2 is 18 plus log base 4 y to the fifth. Okay, take a look at that. Make sure that you understand it. If I've made any mistakes, reach out and let me know. Okay, I'm working through this quickly, try to get it to you. All right, 24, we're going to solve for x. We have 3 log base 2 plus log base, or log x. All right, let me start again. I'm trying to rush. All right, 24 is 3 log base 10, the natural log, not the natural log, the common log. So log 2 plus log x equals log 24. So again, if the base is not written, it's base 10. All right, so we're adding. I can go ahead and take that 3, put it up here, 2 to the third. So log of 2 to the third plus log x equals log 24. Okay, so now I can multiply these two together. Okay, so I have log of 2 cubed times x equals log 24. Let's go ahead and expand 2 cubed. 2 cubed is 2 times 2 times 2. That's 8x. So log 8x is equal to log 24. All right, let's take that out. 8x is equal to 24. Solve that equation. Divide by 8. X is equal to 24 divided by 8, 3. All right, that's it. Went through this quickly, so check your work, check my work, study for your test, and good luck.